thermodynamics. Today we will discuss the new topic chemical equilibrium. So what is chemical equilibrium? First, reactions are two types. First one, irreversible reactions. Irreversible reactions. Irreversible reactions. And second category, reversible reactions. Reversible reactions. Okay. First category, irreversible reactions. And second category, reversible reactions. What are irreversible reactions? A unidirectional reaction in which reactants is completely converted into products. Reactants are completely consumed and the reaction goes to completion in a definite time, of a period. So, what are irreversible reaction? Reactant reactant is completely converted into product. Converted into product. Converted into product. Okay. Reaction is completed. Reaction is completed. Reaction is completed. Okay. Next, unidirectional 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 nature. Unidirection nature. Okay. These are the characteristics of irreversible reactions. So, what are irreversible reactions? A unidirectional reaction in which reactants are completely consumed and the reaction goes to completion. And reaction goes to completion in a definite time of period. Reaction goes to completion in a definite time of period. Last point. Reaction goes to completion. Reaction goes to completion. Completion in a definite time period. In a definite time period. In a definite time period. Okay. These are the characteristics of irreversible reactions. Okay. These are the characteristics of irreversible reactions. Examples of irreversible reactions. A reaction between strong acid versus strong base is a reversible reaction. Reaction between strong acid versus strong base is an example of irreversible reaction. It is an example for irreversible reaction. Example, HCl plus NaOH gives rise to NaCl plus H2. Okay, H2SO4 plus H2SO4 plus 2NaOH gives rise to Na2SO4 plus 2H2O. Okay. So all strong acid, strong base reactions are irreversible reactions. And second one, precipitation reactions. Precipitation reactions. Precipitation reactions. Precipitation. Precipitation reactions. Okay. Example: silver nitrate plus NaCl gives rise to AgCl is precipitated plus NaNO3. NaNO3. All precipitated reactions are irreversible reactions. All precipitated reactions are irreversible reactions. Okay, AgNO3 plus NaCl gives rise to AgCl precipitation plus NaNO3. Next, another example is barium chloride BaCl2 plus H2SO4 gives rise to BaSO4 gives rise to BaSO4 precipitation reaction BaSO4 plus 2HCl. BaSO4 plus 2HCl. Reaction between barium chloride and sulfuric acid is a irreversible reaction. And third category, reactions in open vessel. Decomposition of calcium carbonate gives rise to CaO plus carbon dioxide gas in open vessel. In a open vessel. In a open vessel is irreversible reaction since carbon dioxide is escaped. Since carbon dioxide is escaped. So this is a irreversible reaction. And next, all combustion reactions, all combustion reactions, all combustion reactions, all combustion reactions are irreversible reactions. Irreversible reactions. Irreversible reactions. Example, combustion of methane. Methane plus 2O2 gives rise to CO2 plus 2H2O. 2H2O, this is irreversible reaction. And a combustion of benzene C6H6 plus 15 by 2O2 gives rise to 6CO2 plus 3H2O. 3H2O. So all combustion reactions are irreversible reactions. All combustion reactions are irreversible reactions. Okay. Next, reversible reactions. Reversible reactions. Reversible reactions. What are reversible reactions? What are reversible reactions? A bidirectional reaction. A bidirectional reaction in which none of the reactant is completely consumed and a state is reached. It is equilibrium state. A biochemical reaction, a bidirectional reaction, a bidirectional reaction in which none of reactant None of reactant is consumed. Is consumed. I repeat, please write down. A bidirectional reaction, a bidirectional reaction in which none of the reactant is completely consumed. Is completely consumed. And a state is reached. And a state is reached. And a state is reached. This is called equilibrium state. This is called equilibrium state. This is called equilibrium state. Okay. Such reactions are called reversible reactions. Example: decomposition of PCl5. PCl5 gives rise to PCl3 plus Cl. N2 plus 3H2 gives rise to 2NH3. 2NH3. In a closed vessel, decomposition of calcium carbonate CaCO3 gives rise to CaO plus CO2 in a closed vessel. In a closed vessel. In a closed vessel. Similarly, H2O liquid. H2O liquid gives rise to H2O vapor. H2O vapor. Next, 2SO2 plus O2 gives rise to 2SO2 plus O2 gives rise to 2SO3. 2SO2 plus O2 gives rise to 2SO3. H2 plus I2 gives rise to 2HI. H2 plus I2 gives rise to 2HI. These are the reversible reactions. A reversible reaction never completion. Reactants are converted into products. Again, products are converted into reactants. Reaction never completes. Reactants continuously converted into products, and products continuously converted into reactants. At a time, at a certain time, a state is reached. A state is reached. That state is called the equilibrium state. Okay, na? At the equilibrium state, rate of forward reaction is equal to rate of backward reaction. First point, at equilibrium, at a equilibrium, at the equilibrium state, rate of forward reaction is equal to rate of backward reaction. Rate of forward reaction is equal to rate of backward reaction. At equilibrium, at equilibrium, at equilibrium, concentrations of concentrations of reactants, reactants and and products remains constant, remains constant, remains constant. Okay, but not equal, but not equal, but not equal. Next, at equilibrium, partial pressures of partial pressures of partial pressures of reactants, reactants and products and products remains constant, remains constant, remains constant, but not equal, but not equal, but not equal. Okay, but not equal. Next point, but not equal. Next, At equilibrium, at equilibrium, at equilibrium, properties, observable properties like properties, observable properties like color, density, pressure, etc. remains constant, remains constant, remains constant. And next point, at equilibrium, delta G is equal to 0. This is very, very important. At equilibrium, delta G is equal to 0. And equilibrium is dynamic in nature. Equilibrium is dynamic in nature. Since reactants are continuously converted into products and products continuously converted into reactants. Reaction never stops. Reactants and the products are continuously converted one to each other. Reaction never stops. That's why equilibrium is considered as dynamic equilibrium. Equilibrium is considered as dynamic equilibrium. Write down. Next. At equilibrium, at equilibrium, all thermodynamic properties, all thermodynamic, all thermodynamic properties. This is important. At the equilibrium, all thermodynamic properties like delta H, delta S, delta G also become constant. Delta S properties like delta S, delta H, delta G also become constant. Also become constant. Also become constant. Okay, next point. A true equilibrium attains in a closed vessel. Generally, chemical equilibrium or physical equilibrium attains in a closed vessel. Okay. Approach of equilibrium is always spontaneous and equilibrium state is the most stable state for any state. Equilibrium approach of equilibrium is always spontaneous. Approach of equilibrium is always spontaneous and the equilibrium state is most stable state for any state. And the equilibrium state is most stable state for any state. I repeat. Approach of equilibrium is always spontaneous. Approach of equilibrium is always spontaneous. Under equilibrium state is most stable state for any state. Most stable state for any state. Most stable state for any state. Okay. So at equilibrium gives free energy. Delta G is minimum, becomes minimum, almost 0. At equilibrium, delta G almost becomes 0. Okay. These are the characteristics properties of equilibrium. Another important property is equilibrium can attain either of the direction. For example, if you take HI, HI gives rise to H2 plus I2. Okay, if you take H2 plus I2, here reactant is HI. If you take HI decomposes to give H2 plus I2. Equilibrium is established. If you take H2 plus I2 as reactants, gives rise to HI. Here also equilibrium is established. So equilibrium can establish either of the direction. either of the direction. So this is characteristic properties of equilibrium. Okay.